Midterm review, Math 3, question 1 through 5. Here we go. The function f of x is graphed in the table below. Evaluate 3 f inverse 4. So one thing you want to know is that is going to be your inverse, which means that this is a y value. So what we're going to do is we're going to look at the 4. We're going to report our x value from this y value. So f inverse of 4 is equal to 0. That means 3 f inverse 4 is going to be 3 times 0. So we'll say 3 times 0, which is, of course, 0, and your answer is going to be 0. Question 2. A function f of x is shown below. Does the f of x have an inverse function, y or y not? What we're looking for on this problem is a horizontal line. If you can draw a horizontal line through the function and hit more than 1 point, then it fails the horizontal line test. Which means that its inverse is not a function because its inverse is a reflection over y equals x. So if you were to reflect that over y equals x, then this point here, let's say, let's see, this looks like negative 1 point something, 0 would be 0, negative 1.7. So that goes somewhere down here. It'd just be a reflection over that line. And anyway, if you do that, it'll look something like this. This is my really crude drawing of it, but let's see here. Oh, no, something like that. You got this little heart-shaped thing going on here. Let's see. Kind of hard to make make that, but you can see right here that its inverse won't be a function because it fails the vertical line test. I'll suffice it to say is it fails the horizontal line test. Its inverse will not be a function. And you're good to go. That also simply means it's not 1-to-1. So, no. Question 3. What is the inverse of f of x equals 12x minus 3? All right, what we're going to do here is we're going to make that y. We're going to switch the x and the y out. So we're going to say x equals 12y minus 3. So in this problem here, you're going to want to solve for y. So we're going to add 3 to both sides. That's going to give you x plus 3. From there, you're going to get x plus 3 equals 12y. And then you're going to divide by 12 from both sides. Leave it as one big fraction, that's fine. Y equals x plus 3 over 12. Better way to write that, of course, is the inverse notation. So you'd say f inverse x, f negative 1x equals x plus 3 over 12. Question 4. A function is graphed below. Which function is its inverse? Graph and Desmos to compare. Okay, so what you want to do when you pull up Desmos is you want to be able to input these functions in. So if I input answer choice A, you can go into your functions here. You don't have any root. You can't do like anything but the square root here. But if you go into functions, you should be able to see way down here an nth root. You can also type in nthroot, and that'll pull up the nth root function. So inverse x plus 1 inside, nth root 3x minus 1, and then nth root 3x minus 1 on the outside, and then nth root 3x plus 1 on the outside. So that should be all of those functions there. And they all look very similar, but one of them is going to be the inverse. So here's one way you can tell. What you're looking for on this problem is you want to see if you can reflect it over the line y equals x. So if I graph the line y equals x, it's going to look like this. And a reflection over that line is going to be, oh, I'm being closed captioned here. A reflection over that line, that's cool, is going to have the, let's see, 0, 1, 1, 0, negative 1, 0, 0, negative 1. It's going to look something like this. I don't know, it's kind of hard for me to draw that, but you're looking for the graph that looks like it crosses at negative 1 on the y-axis and positive 1 on the x-axis and continues on its merry way. So let's see what that looks like on Desmos. So if I hide, let's see, if I hide all these and just do one at a time, this one is too high, right? I want it to be at negative 1, so it's not going to be A. Looks like this one is the winner. Let's just verify the other two. That one's let's see. It does cross at those points, but it's not centered. See where that's centered right over there at 1? This one's centered right here, so that's no good. And then this last one here, that's too high. So it is going to be answer choice B in this scenario. There you go. So that is the winner. Next question. What are the solutions for the absolute value equation? Negative 2, absolute value 2x minus 4 plus 2 equals negative 12. I'm going to work this out by hand, and then I'll show you how to do it on Desmos. By hand, you're going to subtract the 2 from both sides. I'm going to isolate the absolute value, so you got negative 2, absolute value 2x minus 4. And then those will cancel out. And negative 12 minus 2 is negative 14. Next thing you want to do is you want to divide by this number out here. Now, negative 14 divided by negative 2 is actually positive 7. So you have the absolute value 2x minus 4, and then that's equal to 7. Now, you're going to write two equations. You're going to have 2x minus 4 equals 7, and you're going to have 2x minus 4 equals negative 7. You're going to solve both of those for x. Now, when you do that, you're going to add 4 to both sides. So you're going to have, 11, and then 11 divided by 2, or approximately 5.5. This one's going to be negative 7 plus 4, so that's going to be negative 3. 2x equals negative 3. Negative 3 divided by 2, which is negative 1.5. So you got two solutions here, positive 5.5 and negative 1.5. Now we're going to back that up with a graph. Now you're welcome to use Desmos graph to assist you. Here's how you do it. When you pull up Desmos, you're going to put the left side of your equation, negative 2, absolute value 2x minus 4 plus 2, into one line. And you're going to put the right side of your equation into another line. Now, if the right side is a number by itself, you want to put y equals. Zoom out if necessary so you can see points of intersection. And we're looking at the two x values where they meet. And you can see negative 1.5 and positive 5.5 are your two solutions. So both of those are real solutions to this equation.